For this example, we're looking at life expectancy for American males. And we have pretty old data here, 2000, 2010. Life expectancy is recalculated, and so with the new census data from 2020, we'll soon be able to update this to something more recent. And so we are told that during this time, it is following a linear trend since the year 2000. And that is really helpful because I know how to make linear equations. I know that linear equations have the formula y equals mx plus b. Also, since this has been going on since the year 2000, I'm going to make the year 2000 be my year 0. And that means I will make 2010 be year 10. All right. So whenever I have data, I have some things already built in. So I know that x comes first and that y comes second. So that's already built in. I don't have to figure that out. It asks me to create the linear model. So the first thing I'm going to do is to figure out slope. So m equals my y2 minus my y1 divided by x2 minus x1. And so I put numbers in, 76.2 minus 74.3, and I'm using 10 minus 0. If I use 2010 and 2000, I would get the exact same answer. So over this 10-year period of time, I do the subtraction, and I see that life expectancy increased by 1.9 years. Dividing that out, I get my actual answer of 0.19. So we're expected to live, males are, 0.19 years longer every year. That's a lot of years in there. All right, so making my formula, y equals mx plus b. I know the slope, so I can write in y equals 0.19x. Now, compared to the previous problems, in this problem I actually know b. Because I made the year 2000 my year 0, I made that my start. This is giving me the starting age. So I know that the starting value, the b value, is 74.3. Now you may be thinking, why did I make this first one 0 when it was the year 3000? Well, the reason is because this was the start of the trend. So as opposed to the previous problem where we were working with linear depreciation, the start of the trend was when we bought the piece of equipment. Here, the start of the trend is the year 2000. And so that's why we want to make that an artificial 0. This idea of making a year be 0 truly only happens with years. So we don't change other data to automatically be 0, just years. And that's because we have numbered our years since many believe the birth of Christ. And so this trend of life expectancy has not been continuing since the birth of Christ. This trend with life expectancy really only started 20 some years ago in the year 2000. Now, we have our linear model. So we did this, create the linear model, check that off. And then I have this second bullet point here that I'm supposed to do. So it says, estimate the life expectancy for a male that was born in the year 2020. So to do that, I need to think about, well, how many years is this into the trend? So the trend started in the year 2000, so I'll minus out 2000, and I find that this is 20 years into the trend. And years is my x, so I will put that into my formula for an x value. And 74.3. And then that is math that my calculator handles very well for me. So put that into my calculator. And I would say that the life expectancy for a male born in 2020 would be 78.1 years. So age 78.1.